Welcome back, guys. So let's take some questions or some problem on stiffness, elasticity. So the first question says, what is the spring constant of a string that needs a force of 3 Newton to be compressed from 40 centimeter to 35 centimeter? What is the spring constant of a string that needs a force of 30 Newton to be compressed from 40 centimeter to 35 centimeter? So the first thing to do is to write the variables given. So variables given, we have that the force F is equals to what? The force given is 3 Newton. And the change in length, a force of 3 Newton to be compressed from 40 centimeter to 35 centimeter. That's the change in length should be equal to, because the force will be compressed from 40 centimeter to 35 centimeter. So we should have 40 centimeter minus 35 centimeter, which is equal to 5 centimeter. Now remember, you have to convert the 5 centimeter to meter. So to convert 5 centimeter to meter, 5 divided by 100. 5 divided by 100, we have 0.05, which is 0.05 meters. Now, introducing Hooke's law, which states that the force applied is directly proportional to the change in length. If we introduce the constant, which is the stiffness, we have force to be equal to K times change in length. K times change in length. So, from the question, we are asked to find the spring constant, which is what? K. So, the change in length is, the value for force is 3 Newton. This is 3 Newton equals to K times change in length, which is 0.05 meters. So to get the spring constant K is equal to 3 divided by 0.05. So our value for K is 60 Newton per meter. Since the value here, we have 3 Newton and this is meter. So this is equal to Newton divided by meter is equal to Newton per meter. So our answer for the spring constant is 60 Newton per meter. So this is the value for the spring constant of the string that needs a force of 3 Newton to be compressed from 40 centimeter to 50 centimeter. So let's take another question. The second question says that, what is the magnitude of a force required to stretch two strings of stiffness 100 Newton per meter and 20 Newton per meter by 6 centimeter if they are in parallel and also in series? What is the magnitude of the force required to stretch two strings of stiffness? The first stiffness is, okay, values given or variables provided. From variables provided, the first stiffness, which is K1, is equal to 100 Newton per meter, and the second stiffness, K2, is equal to 200 Newton per meter. So the question says, what is the magnitude of the force required? We are asked to find the magnitude of the force required to stretch two strings of stiffness 100 newton per meter and 200 newton per meter by 6 centimeter if they are in parallel also in series. So the 6 centimeter is the deformation, which is the change in length, deformation or extension. The change in length is 6 centimeter. So we have to convert this 6 centimeter to meter, which is to convert from centimeter to meter, we divide it by 100. So we have 6 divided by 100. 0.06 equals to 0.06 meter. So now we are asked to find the magnitude of the force. So now from Hooke's law, remember Hooke's law states that the force applied is equal to or is directly proportional to the deformation of the material, which is the change in length of the material. So if you introduce a constant, which is the stiffness K, we have F is equal to K times change in length. Now, the first question says when the spring is in parallel, when the two springs are in parallel, when the spring are in parallel, so we have F to be equal to K net times change in length, which is equal to the value for F. We are asked to find the value for the force, the magnitude of the force, which is equal to the K net is K1, the first stiffness plus the second stiffness times the change in length. So we have 100 plus 200 times change in length. The change in length is 0.06 meter. So if you punch your calculator, the value for the force will be equal to 100 plus 200 is 300. So we have 300 times 0.06 meters, which is 18 Newton. So our value for the force is what? 18 Newton. When the springs are in parallel, the magnitude of the force is 18 Newton. So when the springs are in series, F is equal to K net times change in what? Length, which is equal to K1 times K2 over K1 plus K2 times what? Change in length. So just substitute the values of K1 and K2. So we have 100 times 200 over 100 plus 200. 100 times 200 will give you 20,000 divided by 300. So this 0 can cancel this 0, this 0 can cancel this 0. So we have 200 divided by 3. 200 divided by 3. So we have 66.7. 66.7 times change in length, which is 0.06. So the magnitude of the force will be equal to 0.6. 4 Newton. So when the magnitude of the force required when the springs are in parallel is 18 Newton. when the springs are in series is 4 Newton. Now let's attempt this another problem. The problem says determine the total extension of two strings each with a stiffness of 100 Newton per meter from which a weight of 2 Newton is hung if the springs are connected in series and in parallel. Determine the total extension of two strings each with a stiffness of 100 Newton from which a weight of 2 Newton is hung if the springs are connected in series and in parallel. So variables given: K1 is equal to 100 Newton per meter. K2 is equal to 100 Newton per meter. Remember from the question, it says that the extension of two strings each with a stiffness 100 Newton per meter. So the weight hung is 2 Newton. That the weight is still the same thing as what? The force. So we have force of what? 2 Newton hung. So we have to find the total extension. The total extension can also be called to find the total deformation. So now from Hooke's law, F is equal to K times change in what? L. F equals to K times change in L, which is change in original length. So when they are in series, when the strings are in series, remember the value to calculate when they are in series is equal to F is equal to what? K net change in length, which is equal to K1 times K2 divided by K1 plus K2 times change in length. So this is the value, this is the formula to calculate when they are in series. When they are in series. So we should substitute the value. The value for F is what? 2 Newton. 2 is equal to the value for K1 is 100. So we have 100 times 100 divided by 100 plus what? 100 times change in length. The change in length is what we are looking for. The change in original length or the total extension, that is what we are looking for. So in series. So now this is equal to 100 times 100 gives you what? 10,000. So we have 10,000 divided by 200 times change in length. So these two 0 can cancel this one. So 100 divided by 2 gives you what? 50. So we have 50 times change in length is equal to 2. Now, if we take 50 to this other side of the equation, we can say that the total extension when they are in series is equal to 2 divided by 50. 2 divided by 50. So we have 2 divided by 50 to be 0.04 meters. 0.04 meters. So this is the total extension when the spring is being connected when the strings are connected in series. So when they are connected in parallel, the formula to calculate is F to be equals to K net times change in L, and F is equal to K1 plus K2 times change in the original length. So F will be equal to K1 is 100 plus 100. K2 is 100 times what? Change in L. So we have the value, if we substitute the value for F is what? 2. So we have 2 equals to be what? 200 times change in L. So the value for change in L will be equal to 2 divided by 200. 2 divided by 200, which is 2 divided by 200. We have 0.01 meters. 0.01 meter. So the value for the total extension of the two strings when they are connected in parallel is 0.01 meter. But when they are connected in series is 0.04 meters. So this is how to solve a strings when they are being connected to get the values of strings, either get the value of the total extension, or to look for the force, the magnitude of the force when they are being connected in what? Strings, and also in what? Series. So see you in our next class.